This is continuation of matrices, and we'll be talking about multiplication of a matrix by a scalar. So what is a scalar? We can multiply any matrix by a constant, which is called the scalar. And we call this operation scalar multiplication. So let's look what this means. So if we have a matrix A, and A equals, first row is 2, 8, and negative 3. Second row is 5, negative 9, and 2. And we're asked to find 3a. So 3a, that's 3 times 8, which means we need to multiply everything inside of our matrix by 3, kind of like distribution. So we need to multiply 3 to every element inside of this matrix. Okay, so we would rewrite this matrix as 3a equals 3, open matrix bracket, top row is 2, 8, and negative 3. And our second row is 5, negative 9, and 2. So now this just looks like a distribution problem. So we multiply 3 to each element inside our brackets. So now we have 3a equals, and we'll do the top row first, which is 2, 8, and negative 3. So the top row, so it's open bracket, 3 times 2, 3 times 8, and 3 times negative 3. And the second row is 5, negative 9, and 2. So then we have 3 times 5. The second element is negative 9, so that's 3 times negative 9. The last element is 3 times 2. Okay, now let's simplify this. So the last thing we do is 3a equals open matrix, and the top row is 3 times 2 is 6, 3 times 8 is 24, and 3 times negative 3 is negative 9. Second row is 3 times 5 is 15, 3 times negative 9 is negative 27, and last is 3 times 2 is 6. And that's simplified, and so that's what the scalar multiplication of a matrix is. Many of the properties that we have learned about in algebra also hold true for matrices. For example, the commutative property of addition. If you remember, the commutative property of addition says that if A plus B, that would equal B plus A. So if we have A plus B, we can rewrite that as B plus A, and it's the same thing. So the associative property of addition, how we group things. So if we have open parentheses A plus B close paren plus C, that equals A plus open paren B plus C close paren. We just changed the grouping, but we'll get the same solution. And last but not least is the distributive property. If we have C open parentheses A plus B close parentheses, that equals CA plus CB. Basically multiplying that C to everything inside of those parentheses. Now we're going to talk about using all these properties and multiplication and addition, a combination of operations within a matrix. So if we have two matrices where A equals open matrix 7, 3 as our first row, and our second row is negative 4, negative 1 closed matrix. By the way, we're on page 163. And B equals open matrix, first row of 9 and 6, second row of 3 and 10, closed matrix. And we're asked to find 5a minus 2b. So some things are happening here. And looking at order of operations, we have to take care of our multiplication first. So we have 5 times A. So that's a scalar multiplication of the matrix. So first thing we need to do is multiply matrix A by 5. And then we have minus 2B. We then need to multiply matrix B, everything inside matrix B, by 2. And then we can subtract them. So let's go ahead and set that up. So 5 times A, we'd write that as 5, open matrix, 7, 3. And the bottom row is -4, -1. Let's go ahead and multiply that. Well, let's write out the whole thing first. So we have 5 times our first matrix minus 2 open matrix. First row is 9 and 6. Bottom row is 3 and 10. So that's what it looks like. So now we're going to distribute. Let's distribute that 5 to everything inside of matrix A. So we'd have open matrix, 5 times 7 and 5 times 3. Second row is 5 times -4 and 5 times -1. Close matrix. Okay. Minus. Now let's distribute through the second one. So we have 2 as our scalar. So we have our first row is 9 and 6. So we get 2 times 9 and 2 times 6 as our first row. Second row is 3 and 10. So we get 2 times 3 and 2 times 10. Okay, now let's simplify these. So looking back at matrix A, the first row, we have open matrix. 5 times 7 is 35. And 5 times 3 is 15. Second row, we have 5 times -4, which is -20. And the second element in the second row is 5 times -1, or -5. And that's closed matrix. Minus open matrix, the second one is we have 2 times 9 on the top row, so that's 18. And then we have 2 times 6, which is 12. Second row is 2 times 3, which is 6. And the second element is 2 times 10, which is 20. So now we have two matrices. And it's asking us to subtract these. So again, we write it open matrix, take the corresponding elements and subtract them. So first we'll set that up. So the top row is 35 in the first matrix and 18 in the second. So that becomes 35 minus 18. The second element is 15 and 12. So we get 15 minus 12. And the second row is -20 and 6. So we have -20 minus 6 as the first element in the second row. And then the second one is -5 and 20. So we get -5 minus 20. Okay, so let's simplify this. So this will equal open matrix, top row, 35 minus 18 is 17. The second element in the top row is 15 minus 12, which is 3. And the second row is -20 minus 6, which is -26. And the last element is -5 minus 20, which gives us -25. So the answer to this problem, finding 5a minus 2b, is top row of 17 and 3, and bottom row of -26 and -25.